Good morning, students. Last class ನಾವು ರೌಲ್ಸ್ ಲಾ ವರ್ಗೂ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ, ಕರೆಕ್ಟಾ? ರೌಲ್ಸ್ ಲಾ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕಿತ್ತು, ಬಟ್ ಎನ್ರೀಸ್ ಲಾ ವರ್ಗೂ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಟುಡೇ ವಿಲ್ ಕಂಟಿನ್ಯೂ ಫ್ರಮ್ ದೇರ್. ಓಕೆ, ಸೊ ರೌಲ್ಸ್ ಲಾ ಏನ್ ಇಂಪಾರ್ಟೆನ್ಸ್ ಅಂದ್ರೆ, ರೌಲ್ಸ್ ಲಾನ ಯಾವಾಗ ಯೂಸ್ ಮಾಡ್ತೀವಿ? ರೌಲ್ಸ್ ಲಾ ಇಸ್ ಯೂಸ್ ವೆನ್ ಎವರ್ ಯು ಟೇಕ್ ಲೈಕ್ ಟೂ ವೊಲಟೈಲ್ ಲಿಕ್ವಿಡ್ಸ್, ಕರೆಕ್ಟಾ? ಸೊ ಲಾಸ್ಟ್ ಕ್ಲಾಸಿಂದ ಏನೋ ಡೌಟ್ಸ್ ಇಲ್ಲ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. ಏನೋ ಡೌಟ್ಸ್ ಇದ್ರೆ ಇವತ್ತು ಕೇಳಿ. ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಯಾರು ಏನೂ ರೆಸ್ಪಾನ್ಸ್ ಮಾಡಿಲ್ಲ. Okay, so we'll discuss about the Raoult's law. So, what are Raoult's law? Okay, so Raoult's law we define for two volatile liquid. You can also define for like one non-volatile solute and one volatile liquid. Okay, so Raoult's law we define for two volatile liquid. When you take two volatile liquids, now what will happen anta kelidre, whenever you take a two volatile liquids, volatile ಅಂದ ತಕ್ಷಣನೇ ಏನ್ ನೆನಪಾಗುತ್ತೆ ನಿಮ್ಗೆ ಅಂದ್ರೆ, okay, so volatile liquids are nothing but they are the liquids which boil at the room temperature, correct? So volatile liquids are the liquids which boil at the room temperature and they will be easily evaporated. So adakke, so what you have to remember is the vapor pressure that is PA is directly proportional to the mole fraction of A. Okay, so they'll tell the vapor pressure of A is directly proportional to the XA. Andre the like what is the vapor pressure of A means like the pressure exhibited by the molecule A is directly proportional to how much mole fraction of A is present in the container. Similar way, the PB, the vapor pressure PB is directly proportional to the XB. PB is directly proportional to XB. Understood? That means the vapor pressure of the respective element should be equal to their XA and XB value. Okay, I'm not solving this question. I'm just using this as a blackboard to, explain the concept. So overall, Dalton's law will tell. Okay, so see, you whenever you have like pure A, right? So the vapor pressure, what is vapor pressure? Vapor pressure is nothing but the pressure exhibited by the vapors on the surface area of the liquid. You consider this is one vapor, right? So in this vapor, if you consider, so vapor on the surface of liquid will exhibit some pressure, no? So that pressure we call it as vapor pressure. Vapor pressure. So that's why they tell, according to the Dalton's law, according to the Dalton's law of the partial pressure, you can tell the total pressure is equals to sum of the partial pressure. The total pressure is equals to sum of the partial pressure. That is P total is equals to PA plus PB. P total is equals to PA plus PB. Then whenever you consider PA is nothing but, when you remove this proportionality, you'll get a constant, that is P naught A XA. Right, students? Then P naught B XB. Okay, make a note of this. That is total pressure is equals to the PA naught XA plus PB naught XB. Okay, so the next one, yeah, done, right? Yeah, so the next one, if you see here, so once you add both of them, like you got the total vapor pressure is equals to PA naught XA plus PB naught XB. Now, what are this XA and XB? There is a relation for that also. Yeah, what is PA naught also to tell? No? 1 minute. Yeah, so when you consider them like this, okay, so when you consider for them, what is the P and PB in the Keltara? Like they will ask what is PA naught and PB naught, right? Yeah. So what is PA naught and PB naught? PA naught and PB naught are the pure solvent vapor pressure. Okay. What is PA naught and PB naught? They are the pure solvent vapor pressure. That means when you consider any two solvent, their vapor pressure will be PA naught and PB naught. PA naught and PB naught will be the vapor pressure of pure solvent A and B. Pure solvent A and B. That we call it as vapor pressure. Got it? So then what is PA and PB? PA and PB is nothing but the vapor pressure of the solution. Solution or vapor pressure of the solution A and B after mixing. After mixing them. And total pressure is the total pressure of the solution. Okay. Then XA and XB. See here, very, very important. XA and XB is nothing but what are XA and XB? XA and XB are the mole fraction, but whenever they are evaporated, are they inside the solution? They will ask, what is XA and XB? So you have to remember that XA and XB are nothing but they are the vapor, mole fractions of the A and B in the solution. Okay. So XA and XB are the mole fractions of the A and B inside the solution. That you should be knowing. Okay. So XA and XB are mole fraction of A and B in solution. Then what is YA and YB? So YA and YB is nothing but this is also same mole fraction only, but whenever it is already evaporated, like you consider this is a container. XA and XB you can find inside the container because which is inside, and YA and YB is outside. Y and YB is outside. So YA and YB is nothing but it's a mole fraction of A and B in vapor state. In vapor state. Please make a note of this. Now I'll do the question on this. Okay. So YA and YB is the mole fraction of A and B in vapor state. Whenever they are already eliminated or whenever they are evaporated from the container, that mole fraction I'll call it as YA and YB. Then how to find YA and YB? There is a formula for that also. That is YA is equals to, yeah. So YA is equals to PA by PT. How to find the YA? If they ask, so YA is equals to PA by PT. Okay. So write down the mole fraction of YA is equals to PA by PT. Then how to calculate PA? I already mentioned PA is equals to PA naught into XA and PT is PA naught into XA plus PB naught into XB. Right, students? Yes. Make a note of it. Once you know the YA, you no need to apply the formula for YB because you have to know that always the sum of the mole fraction is equals to 1. That means XA plus XB is equals to 1. Similar way, YA plus YB is also equals to 1. This you should be knowing. Okay. XA plus XB is equals to 1. Similar way, YA plus YB is also equals to 1. Yeah. So YA plus YB is equals to 1. Make a note of this. So this is the overall formulas you have. Okay. If anybody have a doubts, you can put a comments. Now I'll solve the question. I'll move next. Okay. So the next one. graph. How to draw the graph for the Raoult's law? Very simple. You take one graph like this. Here you start with when the mole fraction of A was 0 and it reaches the mole fraction up to 1. Okay, it reaches the mole fraction of A up to 1. Same, you consider YA is equals to 0 here, or sorry, XB is equals to 0 and it reaches XB is equals to 1. See, since there are the formulas is like this, M1 X1 plus M2 X2, you got a 2 slope. You can show the 2 slopes in one direction, but I want to differentiate. So what I do now, I'll draw the 2 graphs simultaneously. So how do I draw? I'll draw like XA is equals to 0, XA reaches 1. Similar way. Y illi xp is equals to 0, which reaches xp is equals to 1. So when you consider like this, the mole, the graph is like this. And here also the graph is like this. And when you join both of them, it is coming like this. Okay. So this graph explains the PA. What is the PA graph explains? PA is nothing but PA naught into XA. Then what will this graph explains? PB naught is equal, PB is equals to PB naught XB. Now when you join both of the points, this gives you the value of PA naught because the mole fraction is 1, right? See, when the mole fraction is 1, can I tell if you substitute 1 here, PA becomes PA naught when the mole fraction is 1? Will you agree? The PA will become PA naught when the mole fraction is 1. Correct, no? Same way, here also, here also you can consider that is PB naught. Yeah, PB naught is equals to 1 here. 1. Then when you join these 2 points, you're getting the total one, that is P total. P total. So P total graph is this, which is equals to PA naught XA plus PB naught XB. PA naught XA plus PB naught XB. Understood, students? So this is the Raoult's law's explanation. Raoult's law is applicable for 2 volatile liquids or 1 non-volatile solute and 1 volatile liquids. Please make a note of it. And anybody, any doubts you have, you can put it in the comment section. I'll take your doubts. Fine. Now shall we do the questions? Yeah. So we'll do the question. Okay, there's one statement question is there, that is the law in which the law which states that the mass of a gas dissolved in a given mass of a solvent at any temperature is what? Oh, something is mistake here. Partial pressure. Yeah. Yeah. This is a question. Which of the following curves represents the Henry's law? They've asked. So how do you do the graph of the Henry's law? Where M is a molality. Where M is a molality. Anybody can comment this in the comment section. What will be the graph for the Henry's law? Go through the question. Which of the following curve correctly represents the Henry's law? So, what will be the answer? So, we have to derive for this. How do you derive this? See, the formula we know is partial pressure okay. So it's the formula is like this. The partial pressure is equals to K into mole fraction. And also when you consider the mass of a gas, oh okay, M is mass not molality. So the mass of the gas is directly proportional to the partial pressure. So when you draw the graph for this, it will get like this. Log M is equals to log P, and if you want to consider the Henry's constant also, you can write as log K. Now you're drawing log M on the y-axis, log P on the x-axis, and it has an y-intercept of log K. Okay, that means the graph should have an intercept. None of the graph, okay, this is not even starting, joining, this is not a curve, and there is no intercept here. Then the only graph which explains about the log K as an value in the graph is only the first one. That's why the first option is correct. Will you agree? Correct? So here the y-intercept should come as log k. That's why the answer is this. Any doubts? Hmm. Next. Yeah. So Raul's question. They mentioned the vapor pressure of ethanol and methanol are this much. That is 44.58 millimeter and 88.7 millimeter of mercury. And an ideal solution is formed at the same temperature by mixing 60 grams of ethanol and 60 grams of methanol. Now they're asking what is the total vapor pressure. Please take down this question and please solve this question. Very, very important. Try the question. You know methanol and ethanol formula, right? So I've given the mass, but they're asking total vapor pressure. So the formula will be like the P total. P total will be equals to PA naught XA plus PB naught XB. Correct, students? Then now XB. Now the thing is you have to find now what is XA and XB, but I've given the mass. First we'll find what is moles. Okay, moles of A. I'll take the A as ethanol, 60 gram. And what's the mass of ethanol? Ethanol is C2H5OH, right? So 24 plus 6 plus 16, which is equals to 46 gram. So 46, you have to do the calculation. That is 46 and 60. Ones are 46, 14 carry, then put 0. Then 46, 46 threes are. Threes are, okay. 60s are 18, 1 carry, 138. Okay, well, I'm getting like 1.34. Okay, I'm getting the moles as 1.34. Check whether you also got the same thing. Then mole fraction of B is nothing but 40 gram is there, and the methanol is just CH3OH. So CH3OH is nothing but 12, 15, 15, 16, 16 plus 16, 32 gram, right? So 32 grams. 32, 12 for 16, 16 plus 16, 32 grams. Yeah, 32 grams. So when you do that, you'll get like 1.8 will be the carry. 2s are 1.2. 1.2 you got. Now from the moles, first find the mole fraction. That is XA is equals to Na mole is 1.34 divided by mole fraction of them is 1.34 plus 1.2, which is equals to 1.34 divided by 1.54. Now you divide 154 by 134. 154 you divide 134. So put 0, put point and put 0. So then 154 into 13. So we'll try the 9s because 154 tens is 1540. So 1540 minus 154. 138 I'm getting. Then maybe then it will be not 9s, it's a 8s. It is 8s. 1232 I got. Check whether you also got the same thing. Yeah, 0.8 I got 0.8. If XA is 0.8, then XB will be 0.2. So now we'll multiply 44.8 into 0.8 plus 1 minute. I'll just use an eraser. You're also doing right. You're also getting the same answer. Check. Once anybody got the answers, you can put in the comment section. Doubts also you can put it in the comment section. Okay, students? Yeah. So partial pressure, that is pressure they've given 88.7 into 0.2 into 0.2. So now we'll do this. So it will be 44 carry, 36, 3 carry, 8 fours are 32, 35. Yeah, 35.60 I got. Then plus, next one here, 8, the 14, 1 carry, 16, 17. 16, 17, yeah, 1774, so that is plus. That means 35 plus 17. So 35 plus 17, approximately it comes 66.9 millimeter. Will you agree? 66.9 millimeter. Check whether you also got the same answer or not. Okay, because I approximated a lot. Here also I approximated. Here I approximated, right? So I'm getting the answer around like 55. But yeah, I approximated the values. That's why I'm getting like this. Fine now? Okay, the answer will be the 66.9. 66.9 millimeter. Okay, fine. Next one. Yeah. Equal moles of benzene and toluenes are mixed. The vapor pressure of benzene and toluene in pure state are this much. Now they're asking what is the mole fraction of the benzene in vapor state. I told you, right? They'll ask the vapor state. Then how do you do in the vapor state? See students, in the vapor state, you cannot define Xa and Xb. Instead of that, you have to define the Ya and Yb. Okay. So now I'll assume benzene as an A and toluene as a B. So Ya. So Ya is equals to Pa by Pa plus Pv. Now both are equal moles. That means mole fraction will be 0.5. So Pa will be equals to Pa naught. Pa naught is 700. So it's 700 into mole fraction will be 1 by 2. The other one is 600 into 1 by 2. Yeah. So which is equals to 700 into 1 by 2 is 350. The below one is 350 plus 300. So which is equals to 350 by 650. Cancel. 5 sevens are 5. 13s are 13 5s are 65. So 13 and 7. 13 5s are 65. 5. Okay, 0.53, not 50, because 13 2s are 26, 13 3s are 39. Okay, 0.53, I got the mole fraction of benzene in the vapor state. I'm not finding Xa again, I'm telling whenever the question comes as a vapor state, that means you have to consider the vapor state itself, that is 0.53, that is Ya is equals to Pa by Pt. Got it, students? Please check whether you also got the same answer. Please solve. Solve inside the class, don't just see. Got the answer? Next one. Next one. The solubility of a gas in liquid will increase with, when you increase in temperature, in amount of liquid taken, decrease in temperature, reduction of gaseous pressure. The solubility will be increased when you decrease the temperature, because I told you that if you increase the temperature, all the gases will try to escape out of the container, right? So the suitable answer for this question is the option number C. Third one, because decrease in pressure or decrease in temperature, it will increase the solubility. Assume it is a gas, is a solute here, not the sol. Don't consider solid. For solids, obviously, if you increase the temperature, the solids will melt, then solubility increases. But if they consider the gas will try to escape out of the container. That's why. Okay? Yeah. Next question. The vapor pressure of pure liquid A is 70 torr at 27 degrees Celsius, and it forms a liquid solution with another liquid B. The mole fraction of B is 0.2 and the total vapor pressure is 84 torr at 27 degrees Celsius. Now they're asking what is the vapor pressure of pure liquid B at the same temperature. Okay, then they're asking what is PV naught, they've given PT. Okay, what's the formula? First data given will write. So first one, the vapor pressure of the pure liquid A. Okay, they've given P naught A. How much they've given P naught A? 70 torr. Correct, students? 70 torr. Next one, it forms an ideal solution with another liquid B. The mole fraction of B, the XB, is 0.2. And then the total pressure is 84 torr. Then they're asking what is the vapor pressure of pure liquid B at 27 degrees Celsius. They are asking what is PB naught. Very, very simple. You can apply the PT formula itself. Why I'm telling like this is, see, you know what is the, PA naught value. You have to find PB naught value. That's all. No? So PT is equals to PA naught into XA plus PB naught into XB. Now, if you consider the PA naught is 70 torr into the mole fraction of A. A we don't know the mole fraction, but we know the B. Correct? If you know the B, can I tell that mole fraction of A is equals to 1 minus XB, which is nothing but 1 minus 0.2, which is equals to 0.8. Check that. Will you agree? Yeah. So 70 into 0.8 plus 84, wait, x into 0.2, which is equals to 84, which is equals to 84. Okay. Which is equals to 84. So now 84 is equals to 7 8s are 56 plus 0.2 hex. So now 84 minus 56. What is 84 minus 56? 8. 7 minus, 28. Okay. So 28 is equals to 0.2x. Then x is equals to 28 by 0.2, which is equals to 280 by 2. Correct? Huh? So 280 by 2, which is nothing but 140 bar or 140 torr. I got the answer as 140 torr. Check whether you also got the same answer. I hope you are able to understand whatever I'm doing. Done? Okay. Okay. Raoult's law is not valid, they're asking. Non-ideal solution showing positive deviation, non-ideal showing negative deviation, mixture of two immiscible liquid. Yeah, all three of them. Okay. I'll tell you the next topic when the Raoult's law is not applicable. Okay. Yeah. So for this, all of this, Raoult's law is not applicable for the non-ideal solutions and also for the two immiscible liquids. If they are not immiscible, and consider they are non-volatile also, then they are not evaporating. If they are not evaporating, you cannot find the mole fraction and vapor pressure. That's why. Understood, students? Okay, fine. Next one. Yeah, the correct option for the value of the vapor pressure of the solution at 45 degrees Celsius with the benzene to octane, they are in the molar ratio of 3:2. And at 45 degrees Celsius, the vapor pressure of benzene is 280 millimeter of mercury and that of the octane is 420 millimeter of mercury. You assume that they are the ideal gases. Okay, you assume that they are the ideal gases. Okay, well solved. They have given the molar ratio, that is N1 is to N2, which is equals to 3 is to 2. Okay, then the vapor pressure of benzene. Assume the benzene is the first one. So PA naught of benzene is 280 millimeter of mercury. Then octane, that is PB naught, is 420 millimeter of mercury. Now you consider for both of them, that is P total. So P total is nothing but PA naught into XA plus PB naught into XB. So PA naught is 280 and mole fraction will find 3 by 5, right, total, because moles are 3 is to 2, that means the total moles is 5. That means particular mole fraction will be 3 by 5 plus for B it will be 420 into 2 by 5. So now we'll do 2 ones are 2 5s are 25, 3 56 3s are. Okay. So I got 168 plus 168. I think 168 plus 168 is nothing but 336 millimeter of mercury. See, there is one option which is 168 millimeter of mercury also. They just kept it. They just kept it. Okay. Done. Okay. Next one. Yeah. So the vapor pressure of pure liquid, okay, it is lowered. Okay, lowered will do. Next. Okay. So next we'll do the colligative properties. I'll do the positive deviation and negative deviation geotropic in the last class since they are theory topic. Next we'll go to the numericals, very, very important topic. That is colligative properties. So what are colligative properties? Colligative properties are nothing but they will be like, what do you say, the properties which just depends on the number of solute particle but not on the nature of solute particle. If any property, if they just depends on the number of particle, that we call it as colligative properties. Understood, student? So here, when you consider the colligative properties, this is a property which depends on the number of particle but not on the nature of particle. Number of solute particle but not on the nature of solute particle, but not on the nature of solute particle. Nature of solute particle. So that we call it as colligative properties. And then in the colligative properties, there are 4 types of colligative properties we are discussing in this chapter. In that, one of the first colligative property which is important is relative lowering of vapor pressure. I hope this is a revision for you, correct now? Because already if it's a first chapter, almost in all the courses it will be completed, right? So you can catch it easily, right? So relative lowering of vapor pressure. Relative lowering of vapor pressure, which we also call it as RLVP, right? Relative lowering of vapor pressure. We also call this as RLVP. RLVP. Understood? So RLVP is nothing but the relative lowering of vapor pressure. So then the second one is elevation in boiling point. Elevated boiling point. That means the boiling point is elevating when you add a non-volatile solute. So elevation in boiling point. I have to still discuss the non-volatile solute case in the Raoult's law. But it's okay. I know what when I'll come to the whatever the topics I've left. I know, so that I'll cover it. Don't worry. So elevation in boiling point done. Next one is depression in freezing point. Elevation in boiling point and depression in freezing point. And then the fourth one is osmotic pressure. The fourth one is osmotic pressure. These are the 4 colligative properties you have to remember for your any competitive exams or for the board exams also. Fine. 4 colligative properties. Yeah. So the next one, I will be starting the first one, that is RLVP. Then we'll do few questions on RLVP. Okay. So, okay, the first one I'm taking is relative lowering of vapor pressure. Okay. So first one you can consider as a relative lowering of vapor pressure. So what is relative lowering of vapor pressure? The name itself is telling relative means original solution. Lowering means the solution's pressure is decreasing. When do the solution's pressure will decrease? When you add a non-volatile solute. Okay. So the concept you have to understand what is happening here in the colligative property. Every time I am taking a non-volatile solute. So consider this is the one container. Okay, you take one container. You take one container and consider this is a solvent, and the solvent is the volatile solvent, and the solvent is a volatile solvent, and the other one is it's a non-volatile solute. It is a non-volatile solute. You are adding to an volatile solvent. Okay, non-volatile solute, you are added that to the volatile solvent. Now what will happen? The vapor pressure of the solution will decrease. Why the vapor pressure of the solution will decrease? Because this non-volatile solute, no, it will be here, right? So it covers the surface area. So now the water molecule, it's not able to evaporate easily because the non-volatile solute is blocking the surface area for the volatile liquids, so that they will avoid the, what you say, uh, the water to evaporate from the container. Okay, the non-volatile solute is blocking the surface area of the liquid and it is not allowing the water molecules to easily evaporate. So if the water molecule is not evaporated easily, then obviously the vapor pressure will be less, right? That's all is relative lowering of vapor pressure. Understood? So what's relative lowering of vapor pressure? When non-volatile solute, when you add a non-volatile solute to a volatile solvent, what is happening? The non-volatile solutes are covering the surface area of the liquid. Now the liquid is not able to evaporate easily. If the liquid is not able to evaporate easily, that means the vapor pressure of the solution will be less. That's all. Understood, students? I hope it's clear. Okay. That is here, that is PA naught minus PA by PA naught is equals to mole fraction of B by mole fraction of A. Or you just take it as mole fraction of, sorry, only take it as mole fraction of B. Moles of B you can take, but yeah. Okay. PA naught minus PA by PA naught is equals to XB, right? So now what is PA naught? PA naught is a pure solvent vapor pressure, okay? So PA naught is pure solvent vapor pressure. Okay. PA naught is a pure solvent vapor pressure. Then what is PA? PA is the vapor pressure of solution. And then what is XB? XB, see, whenever in this chapter, when we use A or 1, A or 1 is a symbol for the solvent, B and 2 is a symbol for the solute. That means we are giving more preference number for the solvents. That's all, okay? So PA is the vapor pressure of the solution, and then XB. So XB is nothing but it's a mole fraction of B. XB is nothing but it's a mole fraction of solute B. Mole fraction of solute B. Okay, solute B. So then this PA naught minus PA, this PA naught minus PA divided by PA naught, this all together it's called as RLVP. RLVP. Then if you just consider PA naught minus PA, then this is called as lowering of vapor pressure. It's called as lowering of vapor pressure. Make a note of it. What's the difference between relative lowering of vapor pressure and vapor pressure? Relative lowering of vapor pressure means divided by PA naught. Just lowering of vapor pressure means need not to be. Need not to be. Done, huh? Done now? Okay, fine. So now I'll do the question. See, if they don't give what is the initial vapor pressure, no, you can assume that as 100. Okay, if they don't give, then you can assume that as 100. Clear? Okay, done. Okay, done. Okay, now we'll do the question. If they don't give PA naught, then you can assume that as a 100. That's what I mentioned. Okay, this is the question. The vapor pressure of pure liquid X is 2 atmosphere at 300 Kelvin. Then it is lower to 1 atmosphere on dissolving 1 gram of Y in 20 grams of X. If the molar mass of X is 200 gram, then what is the molar mass of Y they are asking? See how easy question this is, direct question. So how to do this kind of question? Okay. See, they've given initially it was at 2 atmosphere. Now it is reduced to 1 atmosphere. Okay. So we'll write the formula PA naught minus PA by PA naught and the mole fraction is XB. Can I write the XB as NB by NA plus NB? Right? So then here you can write. See, if you want to write that like Na plus Nb, that also you can write. Or if you want to ignore the Nb in the denominator, that also you can do. Because it's just very less now, 1 gram in 20 gram. If you want to neglect, you can neglect the Nb in the denominator. So Nb, mole fraction, moles of Nb, 1 gram, we don't know mass, divided by 20 gram by 200 is equals to, initially it was 2 minus 1 by 2, which is equals to 2 minus 1 is 1 by 2, which is equals to 1s are 10s are, which is equals to 10 by x. Then x is equals to 20. X is equals to 20. Check whether you got it or not. What did I do in the denominator? Since it was like 1 gram in 20 grams. See, 1 gram in 20 gram. That means the mass of Y is very, very less. So, since the mass of Y is very, very less, what I am doing, I am ignoring, since the moles of B also will be very, very, very less than the moles of A. That's why I am neglecting, I am writing the Na plus Nb as it is equals to Na only. It is equals to Na only. Got the answer? Okay. Okay. They mentioned here the relative lowering of vapor pressure of the solution containing non-volatile solute is directly proportional to the mole fraction of the solute. This statement is which one? Henry's law, Dulong's-Petit's law, Raoult's law, Lee-Chatelier's principle. Obviously Raoult's law, because Raoult's law is the one which relates the vapor pressure with the mole fraction. Okay. Then they are also asking the relative, the Raoult's law states that for the dilute solution, the lowering of vapor pressure is equals to the mole fraction. Relative lowering of the pressure is equals to the amount of solute present in the solution. The relative lowering of vapor pressure is equals to the mole fraction of the solution. or the vapor pressure of the solution is equal to the mole pressure of the solution. Okay, the option obviously you know it's a third one. Why? The relative lowering of vapor pressure is directly proportional to the mole fraction of the solution. Is directly proportional to the mole fraction of the solution. Okay. Next one. Yeah, we did this. This question. The vapor pressure of the benzene at a certain temperature is 640 millimeter of mercury. Then you're adding a non-volatile, non-electrolyte solid weighing 2.157 gram, which is added to the 39 gram of the benzene. The vapor pressure of the solution is become 600. Now they're asking what is the molecular weight of the solid substance, same as the previous question. Initially it was 640, now it is 600 by initial 640 is equals to 2.175 by x divided by 39 divided by benzene. Benzene mass is C6H6 78. Yeah. Benzene is a solvent, no? That's why. So ones are, twos are. So which is equals to 40 by 640 is equals to 2.175 into 2 into 2 into 2. Into 2 divided by x. Now I want the x. So 1010 cancels, 4 ones are, 4 16s are. So which is equals to x will go above. So it's like 2 into 2.175 into 16. So 16 twos are is 32. So 32 into 2.175. So 32 into 2.175 is nothing but 32 twos are 64. So yeah, I think none of the answer above. Correct? Yeah, none of the answer above, no? Because 32 2 size is already 64, then that means 32 into, maybe the answer is not given above. You can take it as none of the above option. Correct? None of the answers are matching because the answer is not 60. Let me check once again. 16 for the 64. 239, 78, okay. 2 into 2.175 into 16. 16 to the 32. 32 into 2.15. 32 into 2.175. Yeah. The answer is 69.6, but they're given in the first option as 6.96. So the correct answer for this is 69.6. So because of that, the answer is not matching. So it is none of the above. Check whether you also got the same thing. Correct, students? See, whatever the points I'm telling, whenever I'm doing the summary, please try to write it in your one notebook, because only another 18 days are there for the January JEE Main. Usually the January JEE Main will be easy compared to the April session, especially the chemistry paper, especially when they do like the starting 2 to 3 days, almost all the questions are like almost related to the NCERT. Okay, and if you are any coaching materials, if you are referring, there you will be getting like different varieties of formulas and all, like how do they extend the formulas present in the NCERT. If you just study those, or if you attend any classes or something, that is also fine. You can easily do it. Okay. So your 12th, if you have all properly, if you're preparing for your boards, you can easily do for the chemistry. Only 11 portions you have to focus a lot. Understood? So like equilibrium, thermodynamics, chemical bonding, structure of atom, right? So these are the chapters you have to focus. Clear? Yeah. So the answer for this is 69.6, but one option is there which is 6.96, which is not matchable. So that's why that is also not the correct answer. Okay, fine. So next one. The vapor pressure of the pure solvent is this. On adding a non-volatile solution, the pressure becomes 0.6 millimeter of mercury. Now they're asking what is the mole fraction of the component A. Okay. Okay. Pure solvent is 0.8. It is reduced to 0.6. So initially it is 0.8. And then they're asking what is the mole fraction of A. First we'll find what is B. So because A I don't know, no, that's why. So 0.2 by 0.8, which is equals to 1 by 4. If XB is 1 by 4, then XA will be 3 by 4. So 3 by 4 is nothing but 0.75. 3 by 4 is nothing but 0.75. Correct? Okay? Okay. So 0.75 is the mole fraction of the B. Clear? Next one. Okay. The relative lowering of the vapor pressure is equals to the ratio between number of dash they're asking. Okay. What will it be? Mole fraction, right? So it's a solute molecule to the solvent molecule. Solute to the total molecule. Solute. Okay. Where is solute? Okay. So obviously it's not solvent. We never considered the solvent in the numerator, right? So that's why the symbol for this or the answer for this will be it's not the solvent molecule. Solvent barala numerator. Solvent won't come in the numerator. So because of that, the solute molecules to the total molecules in the solution. Okay. Solute molecules to the total molecules. And you can ignore sometimes like you can ignore the solution also. But yeah, solute molecules to the total molecules in the solution. But sometimes we also consider the solute molecules to the solvent molecule. Correct? No? That is only when the concentration is very less. Okay. Yes. The option B seems correct. Next one. The relative lowering of vapor pressure of the solution is 0.2. Now, what is the mole fraction of the non-volatile solute? Okay, obviously, if the relative lowering of vapor pressure, that means P entire value, PA naught minus PA by PA naught, PA naught minus PA by PA naught. If this entire value is directly proportional to XB. If this is 0.2, obviously this also will be 0.2. So the answer is 0.2. If they would have asked A, then it is 1.0.1 minus 0.2, which is equals to 0.8. I hope you understood the relative lowering of vapor pressure concept. Next class we'll do elevation in boiling point, depression in freezing point, and osmotic pressure. Is it okay? Fine. Thank you.